This is part 4 in a series of videos in which I am restoring this ASR33 Teletype machine. In the previous video I started work on this, which is of course the receiver or printer, and I took the motor out. I have now tested the motor. It tests fine, spins nice and freely, smoothly, no leakage, and it runs as it should, so no excess current or any weird noises coming out of it. And the next issue I had with this was just going through and checking the various parts of the mechanism. It is quite simple to do that, at least it is once you remove the motor. And so what I was doing was slowly rotating this by hand. Now initially it was very tight, and that's one of the reasons I don't like running these on the motor straight away, because either you can burn out the motor or do some damage to something if something's jammed up. As I say, it was very tight. Now I didn't find anything that was anything specific that was seized or excessively tight. It was just a combination of pretty much every moving surface was dry and was dragging or was slightly tight. So I've been going through, lubricating it all, cleaning it up. I've had to make a few adjustments, but now it rotates very nice and freely. So there's almost no effort at all now required to rotate it, which is what I was aiming for, and it seems to work. If I induce a particular character, such as a space, which you can do just by pushing down on these at the right time, then it does advance the carriage and it does the various things that it's supposed to. As I say, I've gone through, lubricated all this. I've checked the various adjustments as far as I can. When it's running slow, it does behave slightly differently when it's going fast. As you can see, it's had a very good clean. I've also cleaned up the distributor. I'll just rotate this. Probably fairly hard to see, but I've cleaned up the distributor surfaces. Be very careful. This is just really a etched PCB, so you don't want to get anything too abrasive on here, otherwise you'll just end up with a bare board. So polish these up, they're nice and clean now. Use the meter and check each one as it rotates to make sure it's making good contact, and that's fine. What you're looking for is to make sure that as you rotate this, that the resistance stays low. You don't want it to be fluctuating too much, otherwise you'll get either poor performance from the machine or it will start arcing and burning away the copper traces. What I might do later on, once I've got the motor back in and done a bit more testing, is we can actually hook this up and start simulating some characters being sent to it. If you do that, and the way we do this is we pass signals through the distributor and then through to the selector solenoid. If you do that, don't do it directly, don't power the solenoid straight through this, because you'll burn these out fairly quickly. Use a small amplifier circuit in a similar way that the machine does itself. Just needs a transistor and a small driver. And so I've done that. That now seems to be fine. I've also had to make some adjustments on the carriage, which is where most of the issues were. The only remaining issue I have that may need attention later is the little bush that the head is raised on. To print, the head is rotated into one of several positions, and then it's raised into one of 4 positions, and it runs up on one side, so it's supported on one side with a little post and bush, and that's quite badly worn. So if I try, pull this across a little bit. So if we try moving this, you can, I don't know if you can see it or not, but there's a lot of play in the bush here, and this is responsible for raising the head to various positions, and it does make a bit of noise when it's raised and lowered. So I may need to make up a replacement bush for this, but I'm going to try it as it is for now. I haven't replaced the pad yet. I'll need to replace that. It's gone hard before I run this at speed. And the only other real adjustments were to increase the belt tension. It's probably still slightly too slack, but I'd rather have it a bit too slack than too tight. But it was way too slack. It was just basically flopping about all over the place. And the only other adjustment was the entire carriage was moving up and down excessively. It's still a little bit loose, but these adjustments are fairly easy to make. There are two concave rollers at the back that run along this bar, and they're fixed, and then on the front there are two rollers that are sitting on eccentrics, and all you do is you slacken the nut off on the bottom, rotate the eccentric, it moves the roller in towards or away from the concave roller, and then you set it so that it's the right amount of clearance. And it's a fairly critical adjustment. When it's right, you'll get almost no vertical play, but very little resistance to motion. The left-hand one was a long way out. This was moving up and down by about 2 millimeters, so you could see it rocking as the machine was going through a cycle. So I've now adjusted that. It now moves freely without too much free play. This side's still possibly a bit slack, but it's not too bad. All the rest of it seems fine. I've checked that everything is free to move. I've lubricated it. There are a number of felt oilers on this. You just impregnate them with oil, and so I've done all those, lubricated all the moving parts, and it now seems ready to have the motor put back in. So that's the next step. I'm going to replace the motor, get it wired in, and then I'm going to try running it to see what happens. I'm kind of looking for a nice, reasonably quiet operation. It will make quite a bit of noise, they always do, but I don't want any unusual noises coming out of it when it's running at speed. So that's the next step. I'll get the motor replaced, and then we'll get back on camera and see what happens. Okay, I've refitted the motor, but unfortunately there is a problem somewhere. The motor does run. At the moment I've got the belt pulled out of the way, so it's just free to spin. I wanted to test it like this first. I did run the motor separately on the bench, and it seemed alright, but it made a bit more noise than I expected. But it's getting extremely, even with no load, it's getting extremely hot. It does run up to speed, and it makes a very loud hum. So I suspect either the motor has got some shorted turns, or there's a fault with the start relay. Now, either way, if it's been run like that for any length of time, then it's probably damaged the motor. It could have been caused by someone trying to run this with the mechanism partly seized. It was very stiff, and that would overload the motor. And with these motors, the way they work is there are two windings. One's a run winding, one's an additional start winding. And when you first power them up, they're both energized. And what should happen is once the motor gets up to speed, the start winding is effectively disconnected by the start relay. But if the motor doesn't ever get up to speed, then so the load's too high on it, then the start winding stays in circuit and the motor will get extremely hot. It's only meant to be energized for a fraction of a second while the motor gets up to speed. So it could be the motor has been fried. What I'm going to do to start with is check the start relay. With any luck, it is just that. But as I said, if it's been run like this for more than a minute or so, then the chances are the motor is destroyed, which will be a bit of a pain. These are very hard to get hold of. I really don't want to have to rewind this. They're very difficult to rewind, but more specifically, it's almost impossible to get them back together again looking right. You can see they're sealed, and once they've been taken apart, it does tend to destroy them. But obviously I can't leave it like this. The motor would just burn out completely within a minute or so of trying to run it, even if it had the power to drive the rest of the mechanism. So I'll start by taking out the start relay, have a look at that, and unfortunately I'll have to dismantle it to properly test it. But we'll have a look at that and see where we can go from there. Okay, I've got the start relay taken apart, and what should happen with this is this coil detects or senses the current passing through the motor, and once it reaches a certain point, these contacts should open. This doesn't look quite right, something seems a bit odd in here. It's a basically a current sense relay. What I'm going to do is run it up, and what we should see is these contacts should open once the motor's started, and I'll run it up and see what happens. I don't want to leave it running too long because, as I say, the motor gets extremely hot very quickly. Okay, so I don't know how much of this you'll be able to see, but I'll power this up. And as you can see, the contacts are not opening, so it's possible that that's the only fault, but chances are if it's been run like that for more than a minute or so, then it will have done some permanent damage to the motor. What I'm going to try and do is manually open the contacts once the motor's started, and we'll see if that has any impact and if it reduces the current being drawn by the motor. You can hear the motor surging as it's trying to go into normal operation, but it can't because the start winding's permanently in circuit. Okay, so I'm going to start at the motor and then open the start winding relay and see what happens. Okay, and you can hear the motor accelerate once I open that contact, so it's possible the motor's fine. The loud hum seems to go away. So I'm going to I'll do this off camera, but if anything spectacular happens, I'll put the camera back on. What I'm going to do is start at the motor, open the contacts, and then I'm going to leave it in that mode running for a while and see what happens. And if it stays cool and runs the way it should, then we can investigate this relay further. But I suspect this relay is broken. Part of it seems to be sort of floating around, which is kind of odd. It's not what I'd expect to see in here. So I'll investigate this, but first thing I want to do is see if we can actually get this to run normally by disabling this relay once the motor's up and running. I need it in circuit to start the motor running, but once it's going I can disable it and see if the motor is viable. Okay, well hopefully you can hear me okay over the noise the motor's making. But what I've done is start up the motor. I've just inserted a piece of the insulation material that came off the machine between the contacts in the relay, and the current being drawn is now about 0.6 amps. It's over 7 amps with this removed, so it does look like the start winding was being permanently left in circuit. It's been running like this now for about 30 minutes, and the motor is making a bit more noise than I would have expected, but it's not too bad. By noise I mean the hum that's coming from it, the 50 Hz hum. But overall it's not too bad and it's not overheating, so I'll leave it running for another 30 minutes, and if it continues to run but doesn't overheat, then I'm hoping that the damage is limited to the start relay. I'll have a look at that start relay and see if it can be repaired, and if it can, I'll repair it, and then we can test the motor and see if it has the power to run the machine, and more importantly if it can run the machine without overheating, and hopefully prove the motor's not got any internal damage. It really depends on if it was left running in that mode for any length of time, which could have caused some internal shorts in some of the motor windings, but they don't look burnt, but you can't always tell from the outside appearance. Okay, it's now been running for almost an hour. The current drawn has stayed pretty much consistent. It's a bit higher than I would have expected for a completely unloaded motor, but it is driving the fans, getting quite a lot of air coming out of this. It seems a bit odd. It's almost like the fan's on backwards. I don't think it is. I think it's just the way that they arranged it, but I would have expected it to be drawing air through the motor, in which case this fan would have to be on the other way around. But that's the way it was when I got the machine, so I'm going to leave it like that and hope it's the right way around. But the motor is still reasonably cool to touch, so it's not getting hot. Hasn't got a load in it, of course, but Even so, if it had shorter turns, it would still be overheating. But it's looking quite promising, so I'm now going to look at the relay and see if I can figure out what's going on with that and why it's not working properly. Okay, so I'm focusing now on the start relay. There's obviously something wrong with it. Firstly, the contact should normally be open when it's not energized. So the way these normally work is there are two windings on the motor, and the common of those two windings goes to the power supply, and the other two ends of the two windings, one is permanently powered from the other pole on the supply, and the second winding should only be brought into play when the motor starts up. So when you first apply power to the motor, current should flow through the permanently attached winding. That is actually in series with the coil that's in this start relay, so current will flow through this coil. But because the motor won't start with just that single winding, a synchronous motor, so it needs to be spinning to actually continue to rotate. And because it's kind of stalled when you first apply power, it draws a lot of current. And because that current is flowing through this coil, it should attract the moving part of the armature in the relay, and that should then cause the contacts to close, and that will bring the start winding into play. And then once the motor starts up and the current flowing through the primary winding drops, the contacts should then open. But these were closed all the time. You saw I had to actually force them open to get the motor to behave itself, and it wasn't caused by the current flowing through the coil. Now, I've been looking at this, and it turns out that for whatever reason this back section of the relay was bent. So though the screws, I don't think the screws had been tampered with. There's two adjuster screws, there's one here, and that sets the operating point of the relay, the current at which it will switch, and there's another adjuster here that you access from outside the relay, and that sets the, if you like, the position, the point at which the contacts make and break. But the armature is pivoted in the middle, and it should work by pulling the contacts close. So you can see I've actually now I've tried adjusting it, but even with the screw back right out, the contacts wouldn't open. You can see now that when I back the screw out, we get a large opening on the contacts. It's possible this just relaxed over the years, and the bend that was put into this gradually came out, and it allowed the contacts to kind of relax into their permanently closed position. And then when the screw was back right out, it still made no difference. You'll see now that if I turn the screw in, I don't know if you can see it or not, but the contacts are closing up. So what I can do now is adjust this to give us a sensible start current. So what should happen is when I apply power, we should see the contacts momentarily close. You'll see a bit of arcing, and then they should open again once the motor started up, and we should hear the motor settle down. And more importantly, the current that's being drawn should drop as well. Okay, so I'll apply some power and keep an eye on the contacts of the relay. So they momentarily closed, but now they've opened themselves again, and so this relay is now working, and the motor current has dropped right down. Now, unfortunately, the motor current does get quite high by the time I get to 115 volts, so it's still possible there are some shorter turns in the motor caused by this being run in this condition for a length of time. The motor will get hot anyway, but as I say, the current suddenly starts to climb, and that is fairly indicative of there being shorter turns. But the fact it runs for quite a long time without overheating means that I think worst case, what I can probably do is run it at maybe 110 volts, and then it should work fine. But I'll run it to full voltage once I've got a load on it. It might just be because there's no load and it doesn't like running at the speed. It's supposed to run up to a synchronous speed with the main supply frequency, and with no load it might not be running up the way it should. But I'll test this a few more times to make sure that it's reliable, and hopefully that will allow us to use this motor and relay. It certainly seems to be behaving itself at the moment, and I'm hoping that's the only problem that we had with it. Okay, so I've got the motor wired back in, and I've refitted the start relay, adjusted it to what I think is the right startup current, and I've now got the motor adjusted so that the belt is attached and tensioned. So I should now be able to start the entire machine rotating. It's going to be quite noisy, of course, these always are, and especially because it's not on its rubber mounts. It's going to be quite loud because it's just going to resonate through the workbench. But it should rotate relatively smoothly. We shouldn't see it kind of starting and stopping and shaking around the bench. It's not stopped in its correct position, of course, so the startup might be a bit sluggish, but we'll see what it does, and hopefully the motor's not going to just start smoking. But also I'm keeping an eye on the current being supplied to the motor, and it should drop down to an amp or so once the motor started up. As I say, it was drawing over 7 amps unloaded before, which was obviously not right. Okay, so I'll apply the power. Okay, well, it seems to work. It's got the power to drive the machine. It's not getting hot straight away. Before 20 seconds and it would have been smoking. So it's now drawing just around an amp, and I've only got it running at 90 volts at the moment. I will what I want to do is run it for a few minutes at low speed, just to let the machine kind of settle down a bit. It hasn't been run for decades, of course. I'll re-lubricate it and then slowly build up the speed, and hopefully it will all free off nicely. If you just try and run them flat out straight away, something's going to be kind of forced out of adjustment or broken, so I don't want to risk damaging anything. But as I say, hopefully the motor is going to be a viable motor. It's looking reasonably promising, but you can't always tell until it runs for a length of time. But okay, that's it for this video. What I'll do now is just pop this back into the base so we can have a quick look, see how it is going to appear, and then in the next video we'll look at the keyboard. So just have a quick look at this sitting in the nicely cleaned up base. Okay, so that's the receiver sitting back in the base, and it's looking much better than it was before. Still got a bit of work to do on this, of course. I've got to replace the pad, and what I'll do then is run the machine up, and in a future video we'll apply some signals to it and try to simulate some serial data coming into it. I have tested the selector solenoid and that seems fine, but what we'll do is build a small driver board just so we can drive the solenoid through the distributor and see if we can actually make this do what it's supposed to. And that's also to further test the drive motor to make sure that we don't have any further issues with it. That's for the future. For the next video, what we'll do is we'll look at the keyboard and see if we can get that working, and we'll go from there. But still a lot of work to do on this yet, but I think it's going to be worth it. I've got a feeling this will be quite a nice machine when it's finished.